Quiz tomorrow, everybody saw that? So not today's stuff, but it's very similar to yesterday's. 2.3, 2.4. Okay, composition of functions. How many times have we seen that word this semester? Every day. F of x, g of x, two functions of x. One can be substituted into the other. You guys have already done this in other courses. Where were we? Hello. 32. It was there. Okay, well now you know. Oh, it wasn't a circle. Let me guess, you can't see brown? So the output of one function is the input of the other. F of g of x means x in terms of f of x, but first you do g of x. Get it? So work from the inside out. That's what you do. So f of x is 5x. G of x is this parabola thing, quadratic guy. What is f of g of 2? Well, first of all, what's g of 2? You know how to do this? I substitute 2 in here, wherever there is an x. So g of x, g of 2, put it there, put it there. So that's 2 squared, and 2 times 2 minus 3. So g of 2 is 4, and 4 minus 3, which is 5. Okay? But I want to know f of g of 2. Well, what's g of 2? So I can substitute that inside this. So that's just asking me what's f of 5. And I got a function f in terms of x. It's 5 times x. So 5 gets substituted in there. And I just go 5 times 5. And we know that's 25. So that's the way I'd recommend you do it. You could also go and put that function, g of x, in here and go f of g of 2. So, well, f of g of 2 would be, I can take this function, put it in there, g of 2. So 5 of g of 2 would be that. Okay, and we will get the same thing. But why not just do it in 2 steps? Make sense? Because this thing's kind of maybe a little bit ugly. Okay? G of f of 1. Now, what's on the inside? It's not g, it's f. So start from the inside out. Are you wondering if you're going to get 3 or 4? Like, are we going to give you 4 function, go, what's f of g of h of q of x? No, we're not. Sorry. So f of 1, let's do that first. That's easy. Just put a 1 in here. F of 1 is 5. So now I want to go g of f of 1, which is g of 5. So I put 5 in this guy and go 5 squared, and 2 times 5 minus 3. So g of f of 1 is 25 and 10. It's 35. Take away 3. It's 32. Okay? Composition of functions. Is that kind of confusing? So I said it, but we didn't write it. f of g of x. That's how you say it, okay? You can also write it like that. So if you see that, that means the same thing. Okay, a couple more. F of g of 5. Well, do that first. What's g of 5? Here's g of x. So wherever there's an x, put in a 5. So g of 5 is 2 minus 5, which is minus 3. Now I want f of g of 5. So f of g of 5 is minus 3. So f of minus 3 is 4 times, wherever there's an x, put in minus 3. And that's negative 12 and 1, which is minus 11. Okay? So f of g of x, well, that says the same thing as that. F of g of x. There's no number this time. What's g of x? Of. It's a lot shorter than writing of. Okay? You know how much time we save by not putting the f there? And then now, we don't really need English, right? This is a universal language. Just what we do, okay?
I thought you just want to put the f there because it might look like after substitution.
There's another reason. Okay. Okay, just don't argue what we do. Okay, that's just what we do. Okay, don't even look there. There it is. F of g of x. Well, start from the inside. I know there's no number there, so that's all I can do, right? I don't know what x is, so g of x is 2 minus, all I'm doing is rewriting this guy up here. So what is f of g of x, which is 2 minus x? Wherever there's an x, I put that in. So 4 times x becomes 4 times 2 minus x plus 1. Okay? And I can simplify this thing. That's 8 minus 4x and 1, otherwise known as 9 minus 4x. Is this going to give us the same thing, you think? Let's find out. G of f of x. So start with the inside. F of x is 4x plus 1. I want g of f of x. So put that in there. 2 minus, don't forget the brackets. Okay, 2 minus 4x minus 1. It is not the same thing. So don't assume you will get the same thing. Definitely not. Okay. Half done. Shorter lesson today. Not too bad. Might be tricky. I don't know. For me, this was the easiest one I've had to prep for this year. Now, we look on graphs. This is a graph of f of x. This is a graph of g of x. I need to know g of f of 2. So just like previously, I'm going to start from the inside. What is f of 2? If I input 2, what's my output? Which one do we do for an input? Which one do we do first when we plot stuff? We do x, don't we? Okay? So what's f of 2? If I input 2, what's my output? It's negative 2. what is g of -2? Well, I go over to my g graph here, and my input is -2. What's my output? That's 3. Okay? So that is g of f of 2. Same thing we just did, only now I'm giving it to you as a graph, not as a bunch of number stuff. G of f of 0. So start there. What's f of 0? That's my y is f of x. I input is 0. What's my output? I'm going to call this 1, okay? Even though it looks like it might be a little bit above 1, let's go with 1. So, g of f of 0, but f of 0 is 1. So what is g of 1? If I input 1 here, what's my output? -1. Okay? Tanner, you with us? G of -2. Start there. What's that? Looks like I already did this thing. That's 3. So I want to go f of 3. So go over to this graph. 1, 2, 3. What's my output? -1. Okay, last one. G of -1 is, there's -1. Can I call that 1? Guess I better not. G of -1 is a half. So what is f of a half? If I go a half here, what's my output? -1/2. It's less than that, I know, but okay. I have a feeling when they maybe did this graph that should have been here, a nice whole number, but that's just a little too far off for my liking, so better call it what it is. Okay? Questions? Not hard, just maybe a little tricky, just maybe like a lot of stuff in this course. Okay, this probably is going to be one of the easiest. Does that ring a bell? That's the formula for a surface area given a radius. In other words, that's a function for surface area given r. So this is SA of r. It's a function of r. I want to express this area as a function of diameter d. So what's the relationship between d and an r in a circle? That's r. That's a d. Yeah, there's 2 radiuses in a diameter, right? So as far as d is concerned, well, d is 2r, but I want r here. So r is a half a diameter. I want the area as a function of diameter. So SA, I don't want in terms of r, I want in terms of d. I can substitute that in there, right? That's a function inside of another function. R is d over 2. R is squared. Don't forget to put brackets there. And I know you guys could have done this in grade 9. We're just looking at it from a different perspective, right? So simplify it if you can. Surface area as a function of d now is 4 pi d squared over 4. 4's cancel out. So that's pi d squared. Looks nicer, doesn't it? Less stuff there. Was that on your formula sheet in grade 10? Anyone remember?
Which one was?
Well, I know this one was. I don't know if that was. Maybe it was. I can't remember.
I think it was.
You know what? I think I've got one right here. I'm just curious. Because that's another way you could have done it.
Maybe not, though.
It is. Both ways are on there. So even if you forgot the relationship between R and D, you still could have done it if they gave you D. Okay, so lastly, well, why would I want to do that? Because now I don't even have to worry about finding the radius, which is half a diameter. I can just use this formula and go SA of 2.5, the surface area of a sphere with a radius, diameter of 2.5 is pi 2.5 squared. And put that in your calculator, and I hope you get that. Do I have units? Yep. It's surface area, so it's squared. Okay, that's it. So again, this isn't on the quiz tomorrow. That says 2.3, 2.4. Is that right, Reese? You might be right. Yeah, I think you're right. That doesn't look right, does it? I don't know. Okay. Well, let me just do it. Yeah, that doesn't look right. That's 3 times about, 7 or so. Pi 2.5 squared is 19.6. That's better. Okay, I don't know where that came from. That's the right one.